Hello everyone, welcome to the course Fundamentals of Manufacturing Processes. In week 10, we'll talk about metal joining processes. This course is offered by Professor D.K. Dwivedi, Department of Mechanical and Industrial Engineering from IIT Roorkee. I'm your TA, Alka Chankit, IIT Kanpur. So, firstly, we'll go through some sample assignment questions which will help you in solving your weekly assignments. And then we'll go through some lecture notes. So first question is related to material removal processes. So first question is the process used for correction of the geometrical and dimensional inaccuracy of holes in the the process is known as, your options are centerless grinding, turning, polishing or boring. So which one answer will be boring? Okay, so it was covered in earlier lectures as well. So in case of this process in machining, boring is the process of enlarging a hole that has already been drilled or cast. So using casting also you can prepare holes which are slightly lesser in dimensions so that you can get better precision and better tolerance. Okay, so by means of a single point cutting tool or of a boring head containing several such tools, such as in boring a gun barrel or an engine cylinder. So boring is also used to achieve greater accuracy of the diameter of a hole, and it can be used to cut a tapered hole. It can be viewed as the internal diameter counterpart of turning, and in case of turning it cuts external diameters. Next question is the working mechanism for the material removal in the case of the lapping process. Your options are cutting by the abrasive embedded in the soft tool surface, or second option is erosion of the material by the hitting of the abrasive with the tool surface. Third is melting by the friction generated by the rubbing of abrasives. Your options are 1 and 2, 1 only, 2 only, or 1, 2, 3, all these statements. So which statements are correct you have to find out. Okay, so in case of lapping process, 1 and 2 will be correct answers. Okay, so this is what lapping process looks like. There will be slurry made of abrasive particles and it can be mixed with the water or oil based liquids to make it in slurry form, and then this abrasive is used for getting finishing of the surface. Okay, so the term lapping is used to describe a number of various surface finishing operations where loose abrasive powders, they are used as the grinding agent at the normally low speeds. It is the process reserved for products that demand a very tight tolerance of flatness and parallelism and thickness or finish. And how lapping works? So lapping is the short form of the loose abrasive process. Okay, so and lapping involves the use of abrasive particles to modify the workpieces, and the abrasive particles are mixed with the water based or oil based liquid, and this combines abrasive and liquid, which are called a slurry, and this is a liquid cutting tool. The slurry is then placed on the rotating motorized platform, which is called lap plate. Okay, the workpiece is then placed against the slurry on the rotating lap plate, and the surface of the workpiece is modified, and rolling sliding action of the abrasive grains between plate and workpiece. These are some of the processes involved in lapping. Okay, so your workpiece and lap plate and abrasive, these three are shown here. Okay, so in this, lapping involves the cutting and shearing action of the loose abrasive particles and the fine grinding of abrasive particles embedded in lap plate. So your workpiece will be moving in this direction, so you will be getting a finishing on this face of the workpiece. Next question is, need of the surfacing process is or are. So which one is correct? So your options are improving the surface properties, hard facing, improving corrosion resistance, or all of these. So the correct answer will be all of these. So in surfacing process, it is a coating type of process. You apply a layer. So surfacing is the application of a layer of metal to the surface of the product by melting the applied metal and the base metal. The common surfacing pool is formed in which the molten metal is mixed with the molten surface layer of the parent metal. It has improved corrosion resistance. So surface finishing can improve a surface's resistance to corrosion. It can reduce friction. It can improve the electrical conductivity. So surface finishing can also improve a surface's electrical conductivity. It can improve durability. So in case of rubber surfacing, which is designed to be durable and shock absorbent, it makes it a good choice for areas like gym and playgrounds. Efficiency, abrasive blasting is a faster and more thorough way to clean a surface than chemical cleaning, which often requires manual scrubbing. Next is, the highest energy density amongst the following welding processes is for. Your options are gas welding, arc welding, laser welding, and electron beam welding. Okay, so highest energy density, it will be in electron beam welding and laser welding are the processes which have highest power density. Okay, so answer will be electron beam welding. So these are some of the processes and their respective heat flux that is used and the temperature that is achieved. Okay, so gas welding uses 10 to the power 2 to 10 to the power 3 watt per centimeter square heat flux, and in case of shielded metal arc welding 10 to the power 4, 10 to the power in case of 10 to the 5 in case of 4 in case of shielded metal arc welding, 5 in case of gas metal arc welding, 10 to the power 6 in case of plasma arc welding, and electron beam welding 10 to the power 7 to 10 to the power 8, and in case of laser beam welding it is 10 to the power 8, around 10 to the power 8. So electron beam welding is known as the highest energy density welding process, and the temperatures are also in the increasing order almost. So gas welding is up to 2.5 to 3,500 3,500 degrees Celsius, and more than 6,000 in case of shielded metal arc welding, from 8,000 to 10,000 in case of gas metal arc welding, and 15,000 to 30,000 in case of plasma arc welding, and 20,000 to 30,000 in case of electron beam welding, and more than 30,000 in case of laser beam welding. So based on the various sources that are used for heating the metal, in case of fusion welding, this temperature keeps on increasing. Next question is the minimum oxygen and nitrogen in the weld metal found in the case of. Your options are gas metal arc welding process, submerged arc welding process, or gas tungsten arc welding process, or the flux core arc welding process. Answer will be gas tungsten arc welding. Okay, so in your notes you are given this particular graph. In this you can see that oxygen percentage and nitrogen percentage in weld is increasing in upper side for oxygen and in this side for the nitrogen. So the one that's having least in both oxygen percentage and nitrogen percentage is the TIGW, which is also known as GTAW, gas tungsten arc welding. Okay, so this one would be the correct answer, and highest will be submerged arc welding will be having highest oxygen percentage, and self shielded arc will be having highest nitrogen contamination in its weld pool. Okay, so the shielding gas flows out of the welding torch surrounding the hot tungsten and molten weld metal and displaces the air which contains oxygen and nitrogen, which then prevents the air. In this way, the air is prevented from having contact with the molten metal or hot tungsten electrode. Next question is the cleaning and sharpening of the loaded grinding wheel is termed as. Your options are dressing, truing, cutting and winding. So answer will be dressing. Okay, so dressing can be defined as the machining process which involves reshaping and sharpening a grinding wheel to restore its original sharpness and surface finish. Its purpose: so dressing removes worn or dulled abrasive grains from the surface of a grinding wheel, exposing new sharp grains underneath. This process also removes clogs and excess bonding material and helps restore the wheel's shape. The benefits are dressing improves surface finish and minimizes vibrations, and it's also necessary to maintain the effectiveness of the grinding wheel, which can become clogged with the metal particles over time. The process: the dressing tool is used to machine the wheel, and to dress a grinding wheel you can use these steps. So first you have to turn on the wheel while standing to the side of it, and we have to place dressing tool's foot on the tool rest and hold it against the wheel as it turns. You have to move the tool side to side across the wheel's surface. Next is the process of restoring shape of the worn out grinding wheel with the help of diamond dressing tool is called. So your options are dressing, truing, cutting and winding. Again same options. Here when diamond tool is used, it is known as truing. Okay, so the process of restoring the shape of a worn out grinding wheel with a diamond pointed tool is called truing, and truing can be defined as reshapes the abrasive surface of a grinding wheel to restore its geometric accuracy and remove damage. Dressing is a slight trimming process to bring a tool into the correct geometric form. Truing is important for maintaining Okay, so in 7th question, The process of restoring shape of the worn out grinding wheel with the help of a diamond dressing tool is called. Your options are dressing, throwing, cutting and winding, and answer will be throwing. So throwing can be defined as the process of restoring the shape of a worn out grinding wheel with a diamond pointed tool, and it reshapes the abrasive surface of a grinding wheel to restore its geometric accuracy, and it removes the damages. Dressing, on the other hand, it is a slight trimming process to bring a tool into a correct geometric form. Okay, truing is important for maintaining optimal grinding performance, which can lead to precise and consistent results. It has improved surface finish, reduced vibration and prolonged wheel life. Some points for truing and dressing grinding wheels. So use a dressing stick that is 1 to 2 steps finer than the grit of your grinding wheel, and avoid using single point and multi point diamond dresser on super abrasive wheels. And resin bond grinding wheels require separate truing and dressing processes, and regular dressing and truing can contribute to a smoother surface finish of the workpiece. Next question is the maximum temperature rise during soldering processes. Options are above 450, below 450, above 750 or below 780. So the correct answer will be, in case of soldering, you use metals which have very low melting point, such as tin, lead and other tin, silver based solders and many more. So in these case your melting point only goes up to 450 degrees Celsius. So correct answer will be below 450. Okay, so soldering is the process of joining two metal surface using solder, which is a filler metal. This process involves heating the surface until the solder melts, when allowing it to cool and solidify. Soldering with alloys that have melting point above 450 degrees Celsius are called hard soldering, silver soldering or brazing. The soldering temperature range is typically between 180 to 450, which is enough to melt the solder, and the exact temperature depends on the type of solder used. In case of lead based solders, it is a good starting temperature is 316 to 343 degrees Celsius, while in case of lead free solders you have a good starting temperature is 343 to 371 degrees Celsius. In case of 6040 solders, it has a set temperature to 370 degrees Celsius. In case of resistance welding, the strength of the weld nugget depends upon your options are the thickness of the electrode, weld nugget diameter, the base metal ultimate strength, or all of these. So the correct answer in this case will be weld nugget diameter. Okay, so strength of a weld nugget in the resistance spot welding depends on the diameter. So in case of fatigue life, as the weld diameter increases, fatigue life increases for concentric tube specimens and single resistance spot welded joints. For tensile strength, different diameters have different tensile strengths. And weld quality, the quality of the weld nuggets determines the quality and strength of the weld and body. Other factors which can also affect this weld nugget, they include welding schedule. The weld schedule is the combination of current that is used, electrode tip force, and the timing of these parameters. Part material, the material of the part that is being welded also affects the the formation of the weld pool or the nugget. The surface conditions and flatness of the part being welded also affect nugget formation, and the electrode size, shape and location, these also affect the final outcomes. Next question is weld bonding refers to. Your options are joining the base metals using gas tungsten arc welding process, or the combination of adhesive bonding and spot welding, or the combination of brazing and soldering, or the solid state welding process. So weld bonding is a combination of adhesive bonding and spot welding. Okay, so weld bonding is a hybrid process which combines both adhesive bonding and resistance spot welding. The combination of these processes can produce joints with better performance than either method alone. So how it works? It combines physical force of welding with the chemical force of adhesive bonding. Benefits: it can produce joints with higher static and fatigue strength, stiffness and crash strength. The process stages, so it typically include squeezing, welding and then hold cycles. Contact resistance: it has higher than the resistance welding due to the adhesive's viscosity. For truing of the grinding wheels, which tool material is used? Your options are aluminum, magnesium, diamond and silicon carbide. Answer will be diamond. Okay, so truing is the operation of changing the shape of grinding wheel as it becomes worn from an original shape owing to the breaking away of the abrasive and bond. Truing is done to make the periphery of the wheel concentric with its axis and to make its side true, and this way to recover the lost shape of the face. Truing is in fact done on the glazed wheels, and the wheel truing is defined as the act of restoring the cutting face of a grinding wheel by removing the abrasive material from the cutting face and sides of the wheel so that it will run true with the respect to its axis of rotation and produce perfect round of or flat work. The wheel truing procedure involves the use of a diamond pointed tool that is fed slowly and precisely across the wheel as it rotates. Okay, now there are lecture notes. So I'll repeat initial questions once more. You joined late, so I think up to 6 after 6 you joined. So initial I'll repeat again. So first question was the process used for the correction of the geometrical and dimensional inaccuracy of holes is. Your options were centerless grinding, turning, polishing and boring. So as I told in earlier lecture as well, so boring is the correction process for the holes, so for enlarging the size. Okay, so answer will be boring. Next question was the working mechanism for the material removal in the case of lapping process, and the statements were cutting by the abrasive embedded in the soft tool surface, erosion of the material by the hitting of the abrasive with the tool surface, or melting by the friction generated by the rubbing of abrasives. So correct statements were 1 and 2 for the lapping process. Okay, so lapping process is loose abrasive process. So here you will be having a lap plate. On this you will be having abrasive particles and your workpiece will be moving in particular direction, giving it finishing. Next question is surfacing process. So need of the surfacing process is, you can improve the surface properties, also hard facing, also improving the corrosion resistance. This is the application of a layer of metal to the surface of the product by melting the applied metal and the base metal. Fourth question was the highest energy density amongst the following welding processes is for. Your options are gas welding, arc welding, laser welding and electron beam welding. So electron beam welding has the highest energy density compared to other processes. Fifth question is the minimum oxygen and nitrogen in the weld metal found in the case of. Your options are amongst these from this graph also you can see TIGW, which is tungsten inert gas welding, or the here gas tungsten arc welding. This is the one which will be having least amount of both oxygen and nitrogen. Concentration is the least here. So this will be the correct answer. Sixth question was the planing and sharpening of the loaded grinding wheel is termed as. Your answer will be dressing. So dressing can be defined as the machining process which involves reshaping and sharpening a grinding wheel to restore its original sharpness and surface finish. Next question was the process of restoring shape of the worn out grinding wheel with the help of a diamond dressing tool is called. Your answer will be truing. So when it's diamond dressing wheel, then answer will be truing. So for others you were present, so I will move to the lecture notes. So in case of lecture 46, in this one material removal processes grinding operations. So there are types of grinding operations. So we'll be talking briefly about these operations. So firstly, what is the definition of grinding? So grinding is mainly for finished parts which are created by other operations. According to grinding machines have been developed to grind plane flat surfaces, external and internal cylinders and contour shapes such as threads, tool rooms, operations for processing cutting tools. So main types of grinding operations are surface grinding, cylindrical grinding, centerless grinding, creep feed grinding or other operations such as honing, lapping and polishing. First process was surface grinding. So in this case there are two types, peripheral grinding and face grinding. These are various types. So in case of plain flat surfaces of workpiece is in horizontal orientations. In case of peripheral grinding, it is performed using periphery. So this is the periphery of the wheel. Okay, so the curved shape. Okay, so using this of the grinding wheel rotating the horizontal axis. Okay, so here this periphery is used for the grinding purpose. And in case of face grinding, the face, so the flat part of the wheel performed using the flat face of the wheel which rotates about the vertical axis. Next is cylindrical grinding. So it has two basic types. First is external cylindrical grinding. So in this case you are using external part for grinding, internal grinding, cylinder grinding. So external part of the grinding wheel is used for grinding the internal part of some cylindrical portion. Okay, there are two types of feed motion that are possible. So traverse feed, in this case grinding wheel is fed in a direction. So here feed is in this direction. or this feed can be in this particular direction as well. So you are rotating and you are keep on increasing this in this movement. So this thickness of this will be keep on reducing and they will be finishing on this surface. Plunge cut. So in upper one, grinding wheel is fed in a direction parallel to the axis of the rotation of the workpiece in figure A, and plunge cut will be grinding wheel is fed radially into the work, which formed grinding wheels use this type of feed motion. Some of the applications are axles, crankshafts, spindles, bearings and bushings and rolls for the rolling mills. Internal cylindrical grinding. The workpiece is usually held in a chuck and rotated. The wheel diameter must be smaller than the original bore hole, so it needs high rotational speeds in order to achieve the desired surface speed. Grinding wheel is fed in either or two ways. So it can have transfer feed or plunge feed. Applications are in finishing the hardened surface of the bearing races and bushing surfaces. Centerless grinding. So in this case you will be having a regulating wheel as well along with the grinding wheel. So in this, reduction in work handling time so that high volume production will be provided. External centerless grinding, it consists of two wheels. Grinding wheel having 1200 to 1800 meter per minute, and in case of regulating wheel it is lower speeds and inclined at a slight angle to control through feed of the work. So this one will be having lower speeds compared to the grinding wheel. Internal centerless grinding. So in this case, two support rolls. So to maintain the position of the work, the regulating wheel is tilted at a small inclination angle to control the feed of the work past the grinding wheel. Some of the advantages that it provides very close concentricity and between the internal and external diameters on a tubular part such as a roller bearing race. Next is creep feed grinding. So it is very high depths of cut and very low feed rates, and depth of cut is 1000 to 10,000 times greater. Okay, so feed, you understand feed that it is moving in this direction, this particular direction will be feed, and in this direction this is the depth. So you are reducing this much depth in one go, but you are moving in this direction your wheel very slowly because of the high amount of removal that is required. Okay, so you have high depth of cut but very low feed rates in this case. Next chapter is joining of metals. So joining can be of various types. So first is mechanical. In this case you can use nuts and bolts, you can use clamps and rivets. In case of adhesives you can use epoxy resins, Fevicol, Quick Fix and M-Seal. In case of welding you can have welding, brazing, soldering. These are various types, these are permanent types compared to these two. Next is each differ based on load carrying capacity. So all these three methods, these vary, their reliability is also different, compatibility and service suitability. So based on various these parameters we decide which one to select for a particular application. So these are the images given for various processes. So joining is a positive process used for assembling different members to get desired configuration. Okay, so this is the gas welding. So in this case, this is the gun which uses acetylene, and combustion of acetylene is used to generate heat, and using that fusion you provide a joint. Next is braze weld. In this case we used mainly copper based alloys for welding. Adhesive welding, so these are the some most organic based adhesives that are used. Mechanical joints, so in this case nut bolt is used. Fusion welding, and then spot welding, this is the resistance spot type welding. So here because of the current that is passed through this, so because of the resistance there will be spot that is formed, because of that there will be welding. Soldering, this is also a pretty basic thing that is used. Now choice of joint. So firstly, when you want to choose which type of welding you require, so firstly you need to decide whether the joint that you want, it should be temporary or it should be permanent. So that will be also deciding factor. So these gas welding and the weldings, fusion type of weldings, they are very permanent compared to soldering and compared to nut bolt type of joining. Requirement of service, temperature, corrosion and reliability, these are also some factors which are required to decide which type of welding is required. Metallurgical compatibility, so the joint that is formed, it is most likely to have different properties, mechanical properties compared to the base metal. So that compatibility will also should be taken into account. Nature of loading, so what type of loading will be there on that particular part that is joined. So if it will sustain static type of loading or dynamic type of loading, that will also decide what type of welding to choose. Metal systems to be joined, whether the metals that you are joining are similar or dissimilar, or whether they have very high melting point or very low melting point, those will also be of crucial. And economy, so how much you can spend on that particular joining operation. Okay, now welding versus other manufacturing processes. So in case of welding process, there will be localized heating. So when you will be, for example here, for this particular part, this will have to go localized heating. So it should sustain that particular heating, that whatever material that you are using. And differential heating and cooling conditions. Residual stresses, so because of high temperature cooling and then subsequent cooling, it will undergo some residual stresses as well. Partial melting, in some cases there can be melting of the base metal as well. Unique weld thermal cycle for all types of welding. Chemical, mechanical and metallurgical heterogeneity. Then reliability of various joints that we are seeing here, it will be different. In case of soldering and adhesive joint, it will be very poor, reliability will be poor, but it is used at the places where you don't require very high strength. Dimensional accuracy and finish, the ductile to brittle transition temperature, creep, heat affected zone, softening and hardening, these are also some factors. And post welding treatment requirement. Now the selection of joining process. So these are various parameters. In case of metal, so what will be the thickness of the sheets, what will be the melting point. So if you are using for example, if you have a tin sheet, then you can't use very high temperature fusion type of weldings. Thermal expansion, this will also this should also be considered. Availability of consumables, criticality of the application, so what application it will be used. For example, if it will be used in nuclear applications or in aerospace applications, then the weldings that will be should be chosen that are very reliable. Service conditions on precision that is required, so there can be much distortion in that case. Then you use weldings that are such as electron beam or plasma type of weldings, which have very high heat flux, so they take less time for the entire welding operation. Economy as well. Economy should be considered if you are using the products in very niche applications. Advantages of welding. So in case of welding, compared to other adhesive based or mechanical joints, these are some advantages. So in case of welding, you will be having permanent joints. So if you have welded two parts together, this joint will be permanent. And joint strength as good as base metal. So the joint, in case of most of the weldings will be having the joint strength as similar to base metal. Economical method of joining, and it is very common method and anywhere. So there are various very easily you can get some part joint compared to some of the other operations such as soldering and brazing. You can get welding done easily. Disadvantages of welding. So it needs expertise. It also requires high labor cost, and it is problematic if disassembling, and there will be hazardous fumes and vapors, and there is poor reliability as well. So at the welded parts, so near the weld there will be always some residual stresses and there will be some distortion there, so that always leads to crack initiation when there is some type of loading is related. So it is not always as reliable as compared to the part that is not welded at all. Now welding processes versus sectors. So resistance welding is used in case of some of the automobile applications. Thermite welding is used in case of railway tracks, so railway joints in railways. Tungsten inert gas welding is used in case of aerospace and nuclear reactors. Submerged arc welding, in case of submerged arc welding, it can provide some waterproof to the particular electrode that you are using as well, so it can be used underwater as well. So for in case of heavy engineering and ship work, this submerged arc welding can be used. Gas metal arc welding, it is used for the pressure vessels. Shielded metal arc welding, it can be used for the general purpose and repairs. Now these are various types of welds that are there: groove weld, fillet weld, bead weld, plug weld and slot weld. And these are various types of joints based on the shapes of the initial geometry. So butt joint, lap joint, T joint, corner joint, edge joint. And welding position, it can be flat, horizontal, vertical and overhead. Next, chapter 48. So firstly, heat force joining. So these are various processes that are related for the joining, the cleaning, for the softening, for the diffusion and melting. These are various processes that are related to the heat. Okay, so and these are the various sources that are used for the heat. So in case of fusion welding, you can use these various processes. So firstly, chemical reactions. So it can be combustion of some gases. It can be the thermite type of welding as well, in which your some oxide will react with the metal which is more reactive compared to the oxide. Okay, so chemical reactions, then there can be electrical resistive heating. So in case of resistance spot welding, you can use electrical resistivity for the heating purpose. So as the electricity will go from the very high resistive wire, so then we know that there will be generation of heat because of joule heating. Next is frictional heating. So because of friction stir welding. In that case, two plates are given relative motion, and there will be some pressure as well towards each other. So there will be, because of that particular friction, these can get welded. Electric arc weld heating. So because of electric arc as well, in case of some of the tungsten electrodes or the metal electrodes that are used. Then radiation heating. So plasma, electron beam heating, all those are related to this. And then interfacial friction or impact. Now in case of chemical reaction, first is gas welding. So in this you have acetylene gas, C2H2. So here triple bond is there between two carbon atoms, and then it is not very stable. So as soon as you provide oxygen to it, it will react and it will form carbon monoxide, which is again not very much stable. So it will again react with hydrogen and oxygen and make carbon dioxide and H2O. Okay, and the combined heat is very high for both of these, which will lead to temperature rise as high as 3000 degrees Celsius. Okay, and the amount of oxygen provided, it will decide what type of flame you will be having, carburizing flame or oxidizing flame, etc. So here this is the what flame looks like. So here inner white cone is there, which has temperature as high as 3100 degrees Celsius, and then you have outer feather part. So it has high heat generation and low temperature region, which has outer blue flame, 1275 degrees Celsius of temperature. Next, other chemical reaction is thermite welding. In this case, you have mixture of metallic oxides and reduction agents. So these are some elements which are more active compared to the elements that are in oxides. So aluminum is more reactive compared to iron, and aluminum is again more reactive compared to copper as well. So as soon as this oxide, ferrous oxide, comes in contact with aluminum, this will lead to this reaction. Also, in addition to this, there will be heat generated, exothermic type of reaction. Okay, so oxides of iron, manganese, copper, chromium will react with the reactive metals such as aluminum and magnesium. Copper oxide with aluminum will also give copper and aluminum, and ferrous oxide and aluminum will give iron and aluminum. Next is electrical resistance heating. In this case, you have heat which is generated by electrical resistance heating, I square RT. So I here is the current. Okay, so the current that is used, so you keep on increasing the amount of current in amperes, you will be getting more and more heat generated. R is the resistance, so resistance, if it keeps on increasing, then again you will be having higher resistive heating. Okay, so that's why when you go for in case of resistive heating, one of the example is the nichrome wires that you use. So those are very high in resistance and they give higher heat as well. Here I is welding current, R is contact resistance or electrical resistance of metal, and T is the time. So the same principle is also used in heaters as well. The coil that is made, it is made using the wires similar to nichrome, which will have very high resistance, and they will provide heat because of that particular current. Heat generation by friction. So the frictional heat generation rate is obtained from, here you have N multiplied by F multiplied by nu. So N is the fraction of energy which will be in between 0 to 1. So the energy that is lost in the friction is converted into heat, and it is friction force. F is the friction force. It is obtained from the product of normal force N and friction coefficient mu. So and nu is the relative velocity. So the higher the velocity, higher will be the heat that is generated. Okay, so although during welding heat can also be generated owing to severe plastic deformation of the metal, if any, like the friction stir welding. Okay, so there can be other sources of the heat generation as well. Heat input versus weld performance. So weld cycle time and so production rate, these are related. Then cooling rate, which in turn affects the solidification rate. Okay, so higher the cooling rate, higher will be the solidification rate. So if solidification rate is very high, your grain size will be smaller. So solidification rate of weld pool determines grain size, inclusion and gas entrapment. So if higher solidification rate, then more gases will be entrapped because they won't be having time to escape from the weld pool. Okay, and inclusions will also be higher. Mechanical properties, inclusion. So from flux, it is lighter compared to the molten metal, so it rises above if it has more time, but if it doesn't have more time, then it will get entrapped inside the weld. Mechanical properties, these will also be different for depending on solidification rate. So for example, if it is a steel is used as the weld metal, then if the formation of martensite is there, then it will be having higher strength but poor ductility, and if it forms perlite because of slow solidification rate, then it will be having a lower strength and also higher ductility. Alloy segregation tendency. So for segregation also you require some time. Segregation will be lower if the solidification rate is very high. Heat affected zone size. So solidification rate, and if you have heated your sample to very high time, higher temperature, then heat affected zone size will be higher. Power density of fusion welding processes. So as you keep on going from this side to this side, you see power density keep on increasing. So the least will be in case of gas or fusion welding. In case of manual arc welding, it is higher compared to gas fusion welding, and the temperature also is high in this case, arc welding. Then you have metal inert gas welding, then you have plasma arc welding, then you have electron beam welding, and then laser beam welding. So as you keep on going to this side, the concentration of the heat at the particular spot will be higher, so density becomes very higher. Okay, so because of that you require very low time for the heating of that particular part, and the depth of penetration also goes very less compared to these initial parts. So heat affected zone will be very small in case of laser beam welding and electron beam welding. Now energy density and time. So how these relate? So total heat input will be energy density times the time. So if your energy density of particular welding is less, low energy density, then you will have to provide extra time for getting to the exact heat input that is required for the welding. And if you have high energy of the particular process, high energy density process, then you will require lesser time. Now these are the advantage. So as you keep on increasing the heat input to the workpiece, then there will be increase in damage to the workpiece. So the microstructure will be distorted, there will be more distortion in the sample, there will be more penetration to the depth of the samples. So all these problems will be there when there is high heat input. Okay, so it will be high in case of gas welding compared to arc welding, and in case of high energy beam welding it will be having lower heat input, but power density of heat source will be higher. Okay, so increasing penetration, it will be having high welding speed, weld quality and equipment cost, these all will be increased. Now effect of heat input. So as the thickness of the particular sample will keep on increasing, then these are the effects of the distortion. So in case of gas tungsten arc welding, as you keep on increasing the thickness, your distortion in angle will keep on increasing. Okay, while in case of electron beam welding, you have almost reduction or almost constant in the distortion, which is very low compared to this tungsten welding. So here you can see the distortion will be very less in case of electron beam welding, and as heat input keep on increasing, tensile strength keeps on decreasing for the weld. Okay, so in various aluminum alloys, it's shown here. So how fast this tensile strength decreases. Okay, so in case of aluminum, magnesium, silicon, it reduces relatively slower the tensile strength compared to aluminum, copper, magnesium and aluminum, magnesium, silicon. Now polarity, so the electrode, DC electrode negative, if it is kept negative, then the pool formation is in this format. So it is very deep weld and there is no surface cleaning. While in case of DC electrode positive, when it is taken positive, then the weld pool is shallow and the surface is cleaning. And in case of AC, there is intermediate formation of this pool, weld pool. Now chapter 49, welding processes. So first is principle of fusion welding. So in this case, fusion of faying surfaces and then subsequent solidification will be there. So in fusion welding, you will be having fusion of the weld as well, the material that is going as the filler metal, and also some partial melting of the base metal. Okay, so after that, subsequent solidification. The sources of heat can be electric arc, it can be gas flame, it can be laser beam, it can be electron beam. So solidification modes can be epitaxial, can be nucleation and growth. So epitaxial meaning the existence, there will be crystal that is already existing, so the remaining molten metal will grow on the existing metal, so the growth will be in that particular orientation which was existing before. And nucleation and growth is the firstly there will be formation of various nuclei, then they will be growing in various directions with time. So we saw this earlier as well, typical structure of oxy-fuel flame, neutral and oxidizing flames. So these are the reactions that take place, acetylene and oxygen. Oxygen, this is your fuel, this is the oxygen, so this will be converted into carbon monoxide plus hydrogen, and this much amount of heat that will be released. Then the carbon monoxide is not very much stable, so it will again react with hydrogen and oxygen and will provide carbon dioxide and H2O, and again more heat. These are the forms of typical oxy-fuel flame. This is the carbonizing type of flame. So here mixture of acetylene and oxygen from the torch, and here at the tip you have around 3000 degrees Celsius temperature. Then you have intermediate flame feather, and here based on this flame there is temperature that is varying with the distance. So at the inner core, inner cone, you have temperature that is keep on increasing up to this part at the highest, then it again reduces for the outer envelope, and in middle part you have acetylene feather which has highest temperature, which is around 3000 degrees Celsius. Need for protection of weld pool. So why there is need for protection of weld pool? So firstly, if you won't use this, then there can be entrapment of atmospheric gases in weld pool. So the oxygen and nitrogen that is present in atmosphere, those gases will get entrapped. So why they will more likely to get entrapped? So in molten metal, as you keep on increasing the temperature of metal, the solubility of gases increases. So the gas will get dissolved in the molten metal, and then as you solidify this, then its solubility reduces. So this will get entrapped, gases will get entrapped, and there will be formation of some inclusions, or they can make the material more brittle. Okay, reaction of gases with weld metal. So these gases can react with your tungsten electrode, which is heated, and it can also react with the molten metal that is there in the weld pool. Then you have contamination of weld pool from the oxides and nitrites. So there can be formation of these oxides and nitrites because of the contamination. So this graph earlier as well. So these are the atmospheric gases versus welding processes. So concentration of nitrogen and concentration of oxygen, so it's keep on increasing in these directions. So as you see in the self shielded arc, you will be having highest nitrogen contamination, while in case of shielded arc welding, submerged arc welding, you will be having highest oxygen contamination, and in case of tungsten inert gas welding, you will be having least both of these contaminations because of the inert gas that is used. Now, why there is protection that is required? Why protection of weld pool? So this pretty much answers the question. Okay, so effect of gases. So the gases, they get dissolved in weld pool, and these gases then form compound inclusions. Okay, so these inclusions will cause when there is some tensile testing or some tensile type of force that is applied, then there is more likely to formation of crack from these inclusion and matrix interface that will act as delamination type of effect. So the cracks will initiate from that particular part. So these render your material low in strength. Effect of nitrogen. So with increasing in nitrogen concentration, you can see with increase you keep on increasing utrious and yield strength of the material, but the elongation ductility will reduce. So toughness of the material will also reduce. Impact resistance is also reducing. In case of oxygen, you have deterioration in all these properties, while in case of nitrogen you had some increase in UTS and yield strength, but here UTS, yield strength also reduce, impact resistance and elongation also reduce with increase in oxygen concentration. Now element transfer efficiency for the manganese, silicon and chromium also reduce with increasing oxygen percentage, as it is more likely to react with these and prevent their transfer. Hydrogen and iron and aluminum. Okay, so hydrogen can also get trapped in these, and so with increasing temperature the hydrogen content is increasing. So, and it is almost same when there is solidification of aluminum and iron is occurring. Okay, so this initially iron is alpha, then it is this particular reaction that will take place and conversion of transformation of alpha to gamma will be there. Okay, so after this reaction there is after gamma, then there is this melting, right? So after melting at the 1536 degrees Celsius, then again the amount of hydrogen content will keep on increasing. So the solubility will keep on increasing as the temperature increases for the metal. And in case of aluminum, it is melting at 660 degrees Celsius. So here this is the how its structure will change. So here it's starting to melt, and this is the liquid part that is forming. Whirlpool protection approaches. So firstly, developing envelope of inactive or inert gases. So argon and other inert gases, these are used. Helium, argon, these can be used for the protection of the this whirlpool, covering pool with the molten slag. So slag can also provide protection from atmospheric gases, or vacuum can also be used. Next is the effectiveness of protection. So it depends on the amount and firmness of the protecting gas. So if the gas that is you are using, if it is heavier and if it is not diluting very fast, then it will be protecting the whirlpool for longer times. Okay, and the amount that is used. Type of protection approach. So which type of protection approach is used? So either you have used molten slag, or if you have used some inert gas, if inert gas, which type of inert gas, and if you have used vacuum. So all these three will provide different type of effectiveness for protection. Next is speed of welding arc. So speed will also determine effectiveness. Type of weld bead, stringer or weaver. Velocity of ambient gases across the arc. So if you have oxygen and nitrogen in atmosphere present, then what is the velocity? This will also decide what the effectiveness of protection. Next is brazing and soldering. So firstly there is soldering. So principle of soldering. A lap joint between two sheets using low melting point 183 to 275 degrees Celsius, and it should have clearance which is controlled, such as 0.075 to 0.125 mm for capillary action. Okay, so for in case of soldering, they are they have wettability which is higher, so they spread very fast. So for capillary action, you should provide some clearance. And to ensure good intermetallic bonding, surface should be free of impurities. Okay, so there should be polished and impurity free. One of the properties is spreadability of the molten solder. So it depends on the fluidity. So why there is eutectic mixtures are always chosen which have very high fluidity. Okay, so for example, lead tin and some of the other eutectic alloy systems are used at the eutectic composition because they have highest fluidity there, because it will be directly solidifying into solid and there won't be any partial solidification, so it will be having highest fluidity. There can be vapor pressure, this can also affect the spreadability. Gravity also helps with this spreadability. Then metallurgical interactions between filler and base metal, and if there is some bondings, then the spreadability will reduce, but there will be good bonding between filler and base metal. Level of alloying between filler and base metal. Next is strength of soldered joint. So in case of soldered joints, there is metallurgical bonds that will be formed. There will be intermetallic compounds that are formed at the interfaces. and the base metal solder interaction determines intermetallic compounds. And if no compound is formed at the interface, then strength is largely determined by the adhesion. Now these are some soldering materials. First is lead tin alloy. Here tin can range from 5 to 70% and lead can range from 95 to 30%. In case of high tin lowers the melting point of alloy and increases the fluidity of the molten solder. These are some of the other solders which don't consist lead. Because of the lead toxicity, these are used mostly because of the some of the rules and regulations related to environment friendliness. So tin antimony solder, here you have 95% tin and 5% antimony. Next you have tin silver solder. In this you have 96% tin and 4% silver. Lead silver solder, in this 97% lead, 1.5 tin and 1.5 silver. In case of tin zinc solder, 91 to 30% tin and 9 to 70% zinc. Cadmium silver solder, it has 95% cadmium and 5% silver. Form of solder and flux for soldering. Now form of solder, so these can be in form of bars and flux cord wires, sheets, foil, ribbon and paste or cream. Fluxes that are used in soldering are ammonium chloride, zinc chloride, rosin and rosin dissolved in alcohol. These are classified as inorganic fluxes which are very active, organic fluxes which are active, and rosin fluxes which are less active. Now these are some of the soldering methods. Soldering irons, which are I think shown here. So this type of gun is used, soldering iron, dip soldering, torch soldering, oven soldering, resistance soldering, induction soldering, infrared and ultrasonic soldering. Now one of the methods is soldering iron. So in this case, solder is touched to the tip of the soldering iron so that molten solder, this is the wire, that is solder, this spreads into the joint surface. Now here also it is shown, this is the solder paste which is there is land, and there this is the workpiece. Then using this gun, there is a heater present, there is a quartz glass, and based on that you use flux as well and you make a solder joint. Brazing flux residue treatment. So in case of brazing flux, it is for rinsing with the hot water followed by drying. Sticky residue fluxes, these are heating and quenching in water. Stream jet followed by wire brushing. In case of soldering flux residue treatment, rosin soldering can be left on the surface of joint. Rosin residue flux remove, so using alcohol, acetone and carbon tetrachloride. In case of braze welding, it is a different process. In this case, braze welding is attractive as base metal melting does not take place, and braze welding is combination of welding and brazing process, and braze welding edges of the plates are prepared. In case of braze welding, groove is filled by using comparatively low melting point filler metal without melting of base metal and the filler metals are mostly brass, which is copper based alloy. Brass is copper and zinc. Okay, and application of braze welding, it is for repair of cracks and broken parts of cast iron and other hardenable steels. In case of welding of cast iron, it needs high preheat temperature and special electrode to produce weld joints free from cracks. In case of braze welding, capillary action plays no role and the filler metal has liquidus above 450 degrees Celsius but below the melting point of parent metals. The filler metal fills the joint like welding with or without the melting of parent metal. Now, in case of braze welding, the molten filler metal and parent metal, they produce adhesion on the cooling, resulting into strong braze weld. So here this is the type of joint that is required, and then in case of welding, fusion welding, there will be some part of the parent metal will be melted as well and will take place, will join this weld. While in case of braze welded joint, the only melting part will be the from the braze filler metal. Okay, so it has two components to be joined with V groove. In case of braze welding filler, brass with 60% copper and remaining zinc with small additions of tin, manganese and silicon. And the small additions of elements improve the deoxidizing and fluidity characteristics of filler metal. The advantages of these processes, so it has low heat input and many related benefits such as low residual stresses, lower distortions, good mechanical properties, lower heat affected zone, non-uniformity in properties of joint, proper fit up and accuracy. Advantage, there is no melting of base metal and there is no problem of metallurgical compatibility. Joints can be disassembled if needed and it has fair strength. Limitations, for brazing you require skilled worker and low service temperature, so it can be generally below 250. If you go above this, then the strength will reduce for the joint. Okay, there is poor strength, galvanic corrosion related problems. So because of the copper based the filler metal that you have used, if you are using it for example on steel, then steel is more active compared to copper, so there will be more of the corrosion, galvanic type of corrosion will be there because of galvanic coupling. Color mismatch, so color of the brazing, it though it looks aesthetically appealing, but it will be mismatched in most of the cases. I'll be going through sample assignment questions once again. First question was, the process used for correction of geometrical and dimensional inaccuracy of holes is, your options are centerless grinding, turning, polishing and boring. So answer will be boring. In machining, boring is the process of enlarging a hole that has already been drilled or cast by means of single point cutting tool, or of a boring head containing several such tools, such as in boring a gun barrel or an engine cylinder. Boring is used to achieve greater accuracy of the diameter of a hole and can be used to cut a tapered hole. Boring can be viewed as the internal diameter counterpart to turning, which cuts external diameters. Second question, the working mechanism for the material removal in the case of lapping process. The options are these are the statements: the cutting by the abrasive embedded in the soft tool surface, erosion of the material by the hitting of abrasive with the tool surface, melting by the friction generated by the rubbing of abrasives. Your options are 1 and 2, 1 only, 2 only and 1, 2, 3. So answer will be 1 and 2. So this is the lapping process, and the term lapping is used to describe a number of various surface finishing operations where loose abrasive powders are used as the grinding agent at normally low speeds. It is process reserved for products that demand very tight tolerances of flatness, parallelism, thickness and finish. The process, it is loose abrasive process. Okay, so lapping involves the use of abrasive particles to modify the workpiece. The abrasive particles are mixed with a water-based or oil-based liquid. The combined abrasive and liquid are called a slurry, and this is a liquid cutting tool. The slurry is placed on a rotating motorized platform called a lap plate. Okay, it's given here. So above this you have slurry of abrasive particles. Okay, the slurry is placed on this lap plate and the workpiece is then placed against the slurry on the rotating plate, and the surface of the workpiece is modified. Rolling and sliding action of abrasive grains between plate and workpiece take place. And here lapping involves the cutting and shearing action of the loose abrasive particles and the fine grinding of abrasive particles embedded in the lap plate. Need of the surfacing process is or are, your options are improving the surface properties, hard facing, improving corrosion resistance, or all of these. So the answer will be all of these. So surfacing is the application of a layer of metal to the surface of the product by melting the applied metal and the base metal. A common surfacing pool is formed in which the molten metal is mixed with the molten surface layer of the parent metal. The improved corrosion resistance, the surface finishing can improve a surface's resistance to corrosion, reduce friction. Surface finishing can reduce friction. Better electrical conductivity. Surface finishing can improve a surface's electrical conductivity. Durability. The rubber surfacing is designed to be durable and shock absorbent, making it a good choice for areas like gyms and playgrounds. Efficiency. Abrasive blasting is a faster and more thorough way to clean a surface than chemical cleaning, which often requires manual scrubbing. Next question is the highest energy density amongst the following welding processes is? For your options are gas welding, arc welding, laser welding, or electron beam welding. Answer will be electron beam welding. So here you can see heat flux and temperatures for all of these weldings. So in case of gas welding, it has the least of both 10 to the power 2 to 10 to the power 3 watts per centimeter square. Okay, in case of electron beam welding, you have the heat flux that is very high, 10 to the power 7 to 10 to the power 8 watts per centimeter square, and temperature also up to 20,000 to 30,000 degrees Celsius. These are the three weldings that have the highest of the temperature and heat flux: plasma arc welding, electron beam welding, and laser beam welding. Next is the minimum oxygen and nitrogen in the weld metal found in the case of. Your options are gas metal arc welding process, submerged arc welding process, gas tungsten arc welding process, and flux cored arc welding. So the answer will be gas tungsten arc welding. So this graph is given in notes for your I think lecture 49. So in that you can see that for the tungsten inert gas welding, it has the lowest concentration of both oxygen as well as nitrogen. So this one would be the correct answer. So the shielding gas flows out of the welding torch surrounding the hot tungsten and molten weld metal, and it displaces the air, which consists of oxygen and nitrogen, which prevents the air. In this way, the air is prevented from having contact with the molten metal or the hot tungsten electrode. Next question is the cleaning and sharpening of the loaded grinding wheel is termed as. Your options are dressing, truing, cutting, and winding. So the correct answer will be dressing. Okay, so dressing can be defined as a machining process which involves reshaping and sharpening a grinding wheel to restore its original sharpness and surface finish. Purpose is that dressing removes worn or dulled abrasive grains from the surface of a grinding wheel, exposing new sharp grains underneath. This process also removes clogs and excess bonding material and helps restore the wheel's shape. Benefits: dressing improves surface finish and minimizes vibration. It's also necessary to maintain the effectiveness of a grinding wheel, which can become clogged with the metal particles over time. Process: a dressing tool is used to machine the wheel. To dress a grinding wheel, you can choose the steps. First, turn on the wheel while standing to the side of it. Place the dressing tool's foot on the tool rest and hold it against the wheel as it turns. Move the tool side to side across the wheel's surface. The process of restoring shape of the worn out grinding wheel with the help of a diamond dressing tool is called. Your options are dressing, truing, cutting, and winding. And in case of diamond tool, the correct answer will be truing. So it is the process of restoring the shape of worn out grinding wheel with the help of a diamond pointed tool is called truing. The truing reshapes the abrasive surface of a grinding wheel to restore its geometric accuracy and remove damage. Dressing is the process of a slight trimming process to bring a tool into the correct geometric form. Truing is important for maintaining optimal grinding performance, which can lead to precise and consistent results. It also has improved surface finish, reduced vibration and prolonged wheel life. Some points for truing and dressing grinding wheels. It uses a dressing stick that is 1 to 2 steps finer than the grit of your grinding wheel. Avoid using single point or multi-point diamond dresser on super abrasive wheels. And resin bond grinding wheels require separate truing and dressing processes. Regular dressing and truing can contribute to a smoother surface finish on the workpiece. Next is the maximum temperature rise during soldering process is. Your options are above 450, below 450, above 750 or below 780. So the correct answer will be below 450. So soldering is a process of joining two metal surfaces under solder using solder. This is a filler metal solder. The process involves heating the surfaces until the solder melts, and then it is allowed to cool and solidify. The soldering with alloys that have a melting point above 450 degrees Celsius is called hard soldering and silver soldering or brazing. The soldering temperature range is typically between 180 to 450 degrees Celsius, which is enough to melt the solder. The exact temperature depends on the type of solder used. Now these are the solders. Lead based solders, which have starting temperature of 316 to 343 degrees Celsius. Lead free solders have a temperature between 343 degrees Celsius to 371 degrees Celsius, and 6040 solder has temperature to 370 degrees Celsius. Next question is the resistance welding. In resistance welding, the strength of the weld nugget depends upon the. Your options are the thickness of the electrode, weld nugget diameter, base metal ultimate strength, or all of these. So the correct answer will be the diameter. Okay, so strength of the weld nugget in resistance spot welding depends on the weld nugget diameter. In fatigue life, as the weld nugget diameter increases, fatigue life increases for concentric tube specimens and single resistance spot welded joints. The tensile strength is different for nugget diameters which have different tensile strengths. Weld quality. The quality of the weld nuggets determines the quality and strength of the welds and body. Other factors which can affect weld nugget that include welding schedule. The weld schedule is the combination of current, electrode tip force and timing of these parameters. Part material. The material of the part being welded affects the nugget formation. Surface conditions. The surface condition and flatness of the part being welded affect the nugget formation. Electrode size, shape and location. So the size, shape and location of the electrode on the part can affect the nugget. Next question is weld bonding refers to. Your options are joining the base metals using gas tungsten arc welding process, or combination of adhesive bonding and spot welding, or the combination of brazing and soldering, or the solid state welding process. So the correct answer will be B. correct answer will be B, the combination of adhesive bonding and spot welding. Okay, so weld bonding is a hybrid process which combines adhesive bonding and resistance spot welding. The combination of these two processes can produce joints with better performance than either method alone. In case of weld bonding, it combines the physical force of welding with the chemical force of adhesive bonding. Benefits: it can produce joints with higher static and fatigue strength, stiffness and crash strength. This process includes squeeze, weld and hold cycles, and the contact resistance is higher than the resistance welding due to the adhesive's viscosity. Next question is for truing of grinding wheels, which tool material is used? Your options are aluminum, magnesium, diamond and silicon carbide. Answer will be diamond. So in case of truing, it is a operation of changing the shape of the grinding wheel as it becomes worn from the original shape owing to the breaking away of the abrasive and bond. Truing is done to make the periphery of the wheel concentric with its axis and to make its side true, and this way to recover the lost shape of its face. Truing is in fact done on glazed wheels. Wheel truing is defined as the act of restoring the cutting face of the grinding wheel by removing the abrasive material from the cutting face and sides of the wheel so that it will run true with the respect of the axis of rotation, and it produces perfect round or flat work. The wheel truing procedure involves the use of a diamond pointed tool that is fed slowly and precisely across the wheel as it rotates. Then grinding operations. So firstly we went through the types of grinding. So grinding is mainly for finished parts, a part that created by other operations, and grinding machines have been developed to grind plain flat surfaces, external or internal cylinders, contour shapes, and for cutting tools. The main types are surface grinding, cylindrical grinding, centerless grinding, chip feed grinding, creep feed grinding, and other grinding operations such as honing, lapping and polishing. Now in case of surface grinding, you have peripheral grinding, in which periphery, this curved part of the wheel, is used for the grinding process. And in case of in case of face grinding, the face of the wheel, which is the flat part, is used for the grinding purpose. Then you have cylindrical grinding, which can have two types: external cylindrical grinding and internal cylindrical grinding. So this might be confusing that which part you are using, initial internal part of this one, this wheel, or the outer part of wheel. So you have to remember, in case of external cylindrical grinding, the external part of wheel is used, while in case of internal, this internal part of the wheel that you are using, that you are finishing, that is used. Then there are two types of feed motions that are possible. So first is transverse feed, in which the grinding wheel is fed in a direction parallel to the axis of rotation of the workpiece. In case of plunge cut, the grinding wheel is fed radially into the work. So it is formed grinding wheels use this type of feed motion. So in this, your wheel is rotating in this direction and feeding is in this particular direction. Okay, and in this case it is parallel to this wheel direction. Then you have internal cylindrical grinding, then centerless grinding, where you'll be having a regulating wheel which will be moving at a slower speed. Internal centerless grinding, creep feed grinding, which will be having very higher depth, but feed rate, which is movement of this wheel in this direction, it will be very slow. Then joining. So joining can be of three types. It can be mechanical join, it can be adhesive join, or it can be welding type of joining. So in case of mechanical, you have nuts and bolts, clamps and rivets. In case of adhesive, you can have epoxy resins, Fevicol, Quick Fix, M-Seal. In case of welding, welding can be welding, brazing and soldering. And how these differ? The resultant product will be having different load carrying capacity, it will have different reliabilities, compatibility will be different, service suitability will be different. These are the various processes. So joining is a positive process used for assembling different members to get desired configuration. Okay, so there you have gas welding, brass welding, adhesive welding, mechanical joints, fusion weld, spot welding and soldering. Now choice of joint. So type of joint can be temporarily or permanent, and requirement of service temperature, that service temperature will also decide, like in case of soldering, you can't use your solder up to 200 degrees Celsius. Above that it won't be of any use. Okay, and in case of welding, you can use it up to higher temperatures. Corrosion and reliability, metallurgical compatibility, nature of loading such as static or dynamic type of loading will be there for the final product. Metal system that is to be joined. So if metal system is dissimilar for both of the parts, then also some weldings can't be used. Economy, all these are some of the factors. Welding versus other manufacturing processes. So in case of welding, you will be having localized heating, there will be differential heating and cooling conditions, there will be formation of residual stresses, partial melting will be there, unique weld thermal cycle will be there, chemical, mechanical, metallurgical heterogeneity will be there in the weld part and the heat affected zones. Reliability will be different for different weldings, and dimensional accuracy and finish, DBTT, ductile to brittle transition temperature, creep, heat affected zone, softening and hardening, post welding treatments, these are also some factors. Selection of joining processes. So these are various factors. In case of metals, the thickness of the sheet, melting point, thermal expansion, availability of consumables, criticality of application, service condition, precision required, and economy. Advantages of welding. So after welding you will be having a permanent joint, and the joint strength will be as good as base metal. Though these joints can be having residual stresses and distortions, and there can be some porosity in those which can be subject your material to the crack initiation. And economical method of joining, this is cheaper compared to other methods and anywhere. So this is also easily availability of the welding machines. Disadvantages. So it needs expertise. For welding you require some experts. It also has higher labor cost. It is problematic if disassembling. It can have hazardous fumes and vapors, and also poor reliability. Now these are some sectors which use these particular welding processes. For example, resistance welding is used for automobile sector. In case of thermite welding, it is used in rail joints in railways. Tungsten inert gas welding, it is used in aerospace and nuclear reactors. The submerged arc welding is used in heavy engineering and ship works. Gas metal arc welding is used in pressure vessels, and shielded metal arc welding is used for general purpose and repairs. These are some of the welds and joints, welding positions. Then we have type of heat, sources of heat. So these are the six sources. So chemical reactions, which can be combustion of acetylene, or it can also be thermite type of reaction. In case of electrical resistive heating, you can provide resistance because of the electricity passage from the high resistance wire. Frictional heating, electric arc heating, radiation heating, and interfacial friction or impact. So chemical reaction, first one is gas welding, in which you have acetylene combustion and you have flame, which will be used for welding. Next you have chemical reaction in thermite welding, which is mixture of metallic oxides and reducing agents. So oxides of iron, manganese, copper and chromium with reactive metals such as aluminum and magnesium. So along with this reaction that is shown here, it is exothermic, so there will be heat production as well. Next is electrical resistance heating. So here heat is generated by electrical resistance heating, I square RT, where I is the welding current, R is the contact resistance and electrical resistance of the metal, and T is the time. Heat generation by friction. So here N times F times V. So here N is the fraction of energy that is lost in terms of friction, and it is from 0 to 1, and F is the friction force, which is obtained from the product of normal force N times the mu. Mu is the friction coefficient. V is the relative speed. Although during welding heat can also be generated owing to the severe plastic deformation of metal, if any, like friction stir welding. Heat input versus weld performance. So weld cycle time and so production rate, cooling rate, which in turn affects the solidification rate. Solidification rate of weld pool determines grain size. So if solidification is very fast, your grain size will be smaller, and the inclusion and gas entrapment tendency will also increase. Mechanical properties will reduce with increasing solidification rate. Alloy segregation tendency will reduce, and because it is time dependent process, both of these, gas entrapment and this gas escape and alloy segregation. Now this is the increasing order for various welding processes. So laser beam, electron beam and plasma, all these have the highest energy densities. Now heat input is given as the multiplication of energy density and time. Okay, so if you have a welding process which is low energy density, then you will have to provide extra time, and if it is less, then you have to provide less time. So, and also heat input for these reactions are given, these methods. So in case of high power density welding, which is high energy beam and arc welding, here you have increasing penetration, welding speed and weld quality, and higher equipment cost. While in case of gas welding, it has increasing damage to workpiece because there is more heat input that is going in workpiece. effect of heat input. So there is distortion as well with increasing thickness. So in case of gas tungsten arc welding, you have more distortion compared to electron beam welding, and the tensile strength keep on decreasing with increasing heat input. This is the effect of polarity on the weld pool. So size of weld pool differs. Then we went through this fusion welding and solidification modes, and this is the carburizing type of flame and how the temperature changes with the distance from this flame. Okay, then need for protection of weld pool. So why? Because of your weld pool can react with the atmospheric gases, leading to the formation of these oxides and nitrites, which will contaminate, and this we already saw. And with this dissolution of these gases, it will lead to compound formation, and these compounds will affect UTS and yield strength. It will increase in case of nitrogen, while elongation and impact resistance decreases. While in case of oxygen, all of these properties deteriorate with increasing oxygen amount. Hydrogen also keeps on increasing hydrogen content with increasing temperature because of the high solubility at the higher temperatures. Now these are various approaches. You can use vacuum, you can either cover this pool with the molten slag, or you can develop an envelope of inactive gases. Effectiveness depends on these particular parameters. So amount and firmness of the protective gases, type of protection approach, and speed of the welding arc. Also type of weld beam, stringer or weaver, or velocity of the ambient gases across the arc. Then we went through brazing and soldering. So soldering is done at lower temperatures, and these are the parameters that affects spreadability of solder: fluidity, vapor pressure, gravity, then strength of solder joints. So they have purely adhesion. It can also have intermetallic bonding as well, and these are various soldering materials. And the form of solder and flux. Then these are soldering methods. Then soldering iron, how soldering is performed. Then flux residue treatment, braze welding, applications of braze welding in case of cast iron and hardenable steels. Then how this looks like compared to fusion welding. Okay, then we went through advantages and limitations. So that's it from my side.